For the entire year, all that was looked up was the sky. The stars were thought to be the lamps of the gods. But only 60 years ago, the chains were broken. When Yuri Gagarin traversed the atmosphere and Neil Armstrong set foot on the moon, humanity took its first baby steps toward becoming a universal species. Launched in 1977, Voyager 1 is the fastest and furthest traveling human-made object. It currently travels at approximately 61,000 kilometers per hour. Sounds incredibly fast, doesn't it? 20 times faster than a bullet. But on a cosmic scale, that speed is no different from a snail's pace. If Voyager 1 were heading to Alpha Centauri, the closest star system to us, it would take 73,000 years to get there. Human history isn't even that old. Trying to reach the stars with chemical rockets is like trying to cross the ocean in a paper boat. If chemical rockets are like paper boats, we need a speedboat to cross the cosmic ocean. To truly leave the solar system, we have to abandon fire and smoke and look into the heart of the atom. Step 1 is going nuclear. Specifically, nuclear fusion, the same engine that powers the sun. With fusion, we're not just burning fuel. We're fusing atoms to release massive amounts of energy. This technology could propel us to 10% of the speed of light. Suddenly, a trip to Saturn isn't a lifetime mission. It's just a few months. But the nearest star is still decades away. To go faster, we need the most potent fuel in the universe: antimatter. This is the holy grail of physics. When antimatter collides with normal matter, it releases 100% of its energy. It is terrifyingly efficient. According to the math, a spacecraft powered by just a few grams of antimatter could reach half the speed of light. The catch? It is an economic nightmare. It currently costs trillions of dollars to make a single gram. And if you make a mistake in containment, well, let's just say you won't have a ship anymore. But let's assume we solve the fuel problem. We still hit a cosmic brick wall: the speed of light. According to Einstein, nothing can go faster. It's the universal speed limit. Unless you cheat. What if we don't move the ship through space? What if we move space itself? This is the concept behind the Alcubierre warp drive. Proposed by physicist Miguel Alcubierre, it suggests wrapping a spaceship in a bubble of energy. This engine compresses space-time in front of the ship and expands it behind. Think of it like a surfer. The surfer doesn't have to paddle. The wave carries them forward. In this scenario, the ship creates a wave in space-time and rides it. Inside the bubble, the ship is technically stationary. This is crucial because it means the crew feels no crushing G-forces, and they suffer no time dilation. They could travel to a star system 10 light-years away and be back in time for dinner, having aged the same as their friends on Earth. The physics actually allows this. The math works. The only thing standing in our way is fueling it with something called negative energy. We don't have it yet, and we don't know how to make it. But the fact that the laws of physics don't say no changes everything. Warp drives are impressive, but they still require traveling the distance. What if we could ignore the distance entirely? What if we could take a shortcut? Enter the wormhole. Officially known as an Einstein-Rosen bridge. Imagine the universe is a flat sheet of paper. To get from point A to point B, you have to cross the entire sheet. But if you fold the paper, A and B touch. You punch a hole through, and suddenly, a million light-year journey becomes a single step. You walk in near Earth, and you walk out near the Andromeda Galaxy instantly. No speeding up, no slowing down. Just a door. Mathematically, general relativity allows for these tunnels to exist. But nature seems to hate them. A natural wormhole would be incredibly unstable. If a single atom entered it, the tunnel would likely collapse and snap shut. To keep it open, we would need to line the throat of the wormhole with that same exotic material, negative energy. If we ever master this, the consequences are mind-bending. A civilization with wormholes doesn't just conquer space, they conquer time. Because according to physics, if you move one end of a wormhole, you could theoretically turn it into a time machine. You could step through and arrive back before you left. Conclusion. So, where does this leave us? We started as primates, looking up at the stars from caves. Today, we are sending robots to the edge of the solar system. Warp drives and wormholes might seem like magic today, but remember, to a person from the Middle Ages, your smartphone would be magic too. Physics doesn't say impossible, it just says hard. And humans are very good at doing hard things. We may be stuck on Earth for now, but our minds are already voyaging among the stars. Thanks for watching. Do you think we will ever break the light barrier? Let me know in the comments. Don't forget to subscribe for more science. See you in the next one.